All right, welcome to another video where we're going to be talking about big O notation and go over some interview questions. All right, so let's go into the first one. So here, as usual, we're going to go over the meaning of the code. Just take it briefly, just to make sure we understand it. This is where this one is going to be taking in an array as the input, and we're just going to be reversing it. Right, it's actually happening in place. There's no extra storage that we're going to have to worry about. So the for loop is going from I equals 0 to the length of the array divided by 2. So we're only going around half of the array. And then it looks like in other equals array length minus I minus 1. So the first iteration, other is going to be the last element in the array. So it's like minus 0, minus 1. So it's like the size of the array minus 1. That'd be the last element in the array. And then the next three, these here, that's just a basic swap. All right, that's all it's doing is just swapping two elements. So it's swapping the first index, so the first element in the array with the last one. That's all it's doing, and it's going to kind of keep coming in and doing that. Okay, that's how it's doing it in place. All right, so now we understand what's actually happening. Let's take a look at what's going on here. We have a for loop and we have a bunch of statements. We have a bunch of assignment operators. So one of the first things we can do is we can eliminate a lot of things here that we don't care about. These assignment operators, as again, are just big O of one operation. No matter what this input array, no matter what the size is, this is going to go over. We're going to perform these n divided by 2 or the array length divided by 2 times, but the actual operation, it's not going to, the time to perform each assignment isn't going to change with the size of the array. It's always going to take the same amount of time to perform it. Okay, that's why they're big O of one. They're constant time. So we got rid of all those, everything inside the for loop. Now all we care about is the for loop. So we're going to substitute array.length for n, which is very common. All right, n being the size of the array or the length of it. So we can say that this is big O of n divided by 2. Okay, so what's actually going to happen here is we're just going to say it's a big O of n instead of big O of n divided by 2. All right, and the reason, think about this, the reason is we can just get rid of the 2 is because let's say the array length is 10. All right, so 10 divided by 2 is 5. Now let's say it's 100. 100 by 2 is 50. If it's 1,000, 1,000 by 2 is 500. So what's happening is the amount of times to go over the loop is going to increase with the size of the input. All right, linearly. So it's going to be big O of n. Right. So anytime we increase whatever the size of the input is, it's still going to perform n divided by 2 times no matter what. So it's going to linearly go together. Okay, and a lot of times one of the big things is you get rid of the constants anyways. One of the two things: get rid of the constants and take the highest order operation. All right, so those are two key things to think about actually whenever you're figuring out the big O notation. But it's also nice to know to kind of give some actual hard examples, and then you can kind of plot them and see that if you plot them on the graph, it's going to be linear time anyways. So the answer to this one is big O of n. All right, remember, just drop the constant. And the reason is if you substitute array.length for some number and plot it, it's still going to look linear time. All right? Okay, so for the next one here, I have something a little bit different for you. I want you to, I have 4 different examples here, and I want you to see which of those are equivalent to big O of n. So go ahead and pause the video, try and work them out, and it's basically like true or false for these. If is big O of n plus p, or p is less than divided by 2, is that equivalent to big O of n? All right, and do the same thing for all of them. And when you're ready to unpause, we'll get back to it and figure it out. All right? Okay, hope you've taken the time to try and figure this out on your own. But if you're not quite sure, you're stuck, we're going to go over them now. So let's take a look at the first one. We have big O of n plus p. Remember, the two things I just said like a minute ago were drop the constants and take the highest order operation. our highest order notation, okay? Which basically means take the worst case of all these. So big O of n plus p, this is the same, we could say big O of n plus, or p is less than n divided by 2. This looks really sloppy, I know. But what is this to say? What this saying is p is always going to be less than half of n. All right. So we could say n plus n divided by 2, or something like that. It doesn't really matter. But either way, n divided by 2 is less than n. So we don't really care. We're going to take the highest order of operation, right? Even if this was just n plus n, which is actually kind of the next example, that'd be 2n. We'd get rid of the constant anyways. But for this example, p is going to be less than n, so we're just going to take n as the answer. All right, so that means that the answer for the first one is just big O of n. Okay. So let's go on the next one. Big O of 2n. This one's rather simple. There isn't much difference between 2n and n, so we drop the constants, and the answer is big O of n. Okay, that's that one. So for the third one, so the first two are good. The first two, they are equivalent to big O of n. So the third one is big O of n plus log of n. Now, log of n is good, right? That's better than n. And so one of the things we wanted to do, big O takes the worst case, so we want to take what the highest order operation is. So that means big O of n is worse than log of n, which is true. N is linear, log of n is better. So we can just eliminate log of n, and this is the same as saying big O of n. All right? Because generally speaking, when we're trying to find the worst case, we're not as worried about the smaller notations. Because they won't affect the time complexity as much as just taking the worst case, right? So that's why you just want to kind of drop them, all right? So that one's a check. Now for this next one, we have big O of n plus m. What does that mean here? That this is something we just went over an example in the last video about this. This means that there's two different inputs here. One, it looks like whatever the n input is, and then the m input. This is not equivalent to big O of n because we can't reduce these. These inputs are distinct from each other, and they both need to be included. So we can't reduce this anymore. We don't know the relationship between them, and we can't assume, and that means we definitely can't assume the relationship between them. All we know is there's two different inputs, and we just have to keep it big O of n plus m. So that is not equivalent. All right. Hope you learned something. If you have any other questions or need clarification or whatever, put them in the comments below, and I'll be more than happy to get to you as soon as possible. All right. I'll see you in the next video.